giving floor to our very dear organizer, the person to whom we owe this whole series of talks, Clelia Crialesi. So Clelia probably doesn't need much introduction by now in here, but anyhow, she's currently an FWO research fellow at the Development Science Center of KU Leuven, and there she's currently working on a project on the development of geometrical arguments in the medieval debate about atomism. At the same time, she's also working on a critical edition for the Aristoteles Latinus project, and the edition is of Pseudo-Aristotle's work, De Lineis Indivisibilibus. And if I can plug in a personal note to that, I first met Clelia when she was a Mellon Fellow. Back then I was a PhD student at the University of Toronto, while she was a Mellon Fellow at the PIMS, so the Pontifical Institute of Medieval Studies in Toronto, where she was working on the Boethian arithmetic and its medieval reception. So we're very much looking forward to Clelia's talk. Clelia, I think the floor is yours.
Thank you, Camille. I'm sharing my screen. Hope you can see it. Okay. So hi, everyone, and thank you for being here. Thank you, Camille, for your very kind introduction. This paper has a peculiar genealogy, which traces back to Albert the Great's account of geometric items. So as simple as that, it might seem a bit puzzling. So allow me to briefly delve into the etiology, so to speak, of the present paper, also to explain how and why I ended up tackling Ps-Marsilius and some other 14th century thinkers and their conceptions of mathematical propositions. So in an article I'm about to submit, actually, I've dealt with Albert the Great's commentary on the physics and on Euclid's geometry. And when focusing on some of Albert's geometric arguments against indivisibilism and trying to explain them in light of Albert's epistemology of mathematics, I realized how crucial the role of imagination is to Albert in order to give reason of the formation of geometric objects ranging from the line to the most complex polyhedron. So it turned out that Albert puts forward a concept of imaginary movement that remained in use throughout the Premodern period. And in this regard, I refer to the recent book by Angela Axworthy, who focuses on the key notion of motion in the 16th century Euclidean tradition, defining it as kinematic understanding of geometric objects. From Albert's perspective, to conceive and build a cube, we start, for instance, by abstracting the mathematical properties from physical objects, and then we manipulate them within our imagination so that we imagine the movement of a point, the flow of a point toward 3 dimensions. Such a conception of motion is at the basis of what in classical geometry is called, genetic definition. That is, to present geometric objects as endowed with mobility and generability. But the key point in Albert's case is that mobility is given by imagination. And precisely because it happens in our imagination, it is oxymoronically defined as a motionless movement. So hence my broader inquiry into the role of imagination in conceiving mathematical items in some later thinkers, still with a special regard to the continuum controversy. And we have extensively talked about that thanks to Cecilia Trifogli's paper and also thanks to Elzbieta and Robert's paper. So the research path I just sketched led me to an article by Henri Huguenin-Roche from 1997, L'hypothétique et la nature de la physique parisienne du XIVe siècle. So as we all might know, in this article, Huguenin-Roche retraces the rise of a specific kind of scientific investigation of nature that we find especially in 14th century commentaries on Aristotle's physics. Such investigation does not proceed only by arguments based in, let's say, in the form of syllogistic deductions, but makes use also of hypothetical propositions, its paradigm being the mathematical science. Now, the view of mathematics as a hypothetical science is something we find within the 14th century nominalist tradition, stemming from the typical nominalist understanding of the objects of mathematics, and more specifically, geometry. So imagination, as we shall see, plays a role in many of the 14th century nominalist accounts of mathematical items and propositions. Now, accounts of mathematics in the nominalist spirit are something which is strictly linked to what John Murdoch defined as the metalinguistic analysis of problems in natural philosophy. And this shift in natural philosophy is marked by a focus on propositions and terms of propositions, which stand for things and events in nature. But this metalinguistic treatment applies especially to the continuum controversy, that is, to the question of the existence of indivisibles constituting continuous magnitudes. So to have a quick idea, nominalist thinkers, wondered whether a point would be considered as an indivisible part of the line, and answered this question by focusing on the meaning of the term point, that is, what the term point stands for, if at all. Now, if we want to keep together the metalinguistic treatment of indivisibles, the role played by imagination in mathematics, and the conception of mathematics as hypothetical science in the 14th century, there is a text we could consider, and which is also mentioned in Hugo Naroche's article, and is also analyzed by Graziana Ciola in her article, The Void and the Chimera, Marsilius of Ingen on Imaginabilia. So it's a late 14th century question commentary on Aristotle's physics, which we can read in an early print from Lyon, with the title of Questiones Subtilissime Secundum Nominalium Viam. And since the title also explicitly states that the text is by a certain John Marsilius of Ingen, the questions have been attributed to Marsilius of Ingen, although now scholarship dismisses the hypothesis it is an authentic work by Marsilius himself. And I leave outside all the problems about the attribution of this text, and I refer to the studies by Harald Berger, Hans Thyssen, and Edith Silla. So to our purpose today, it doesn't matter whether it is by Marsilius or not, because in my talk, this text represents only the starting point to take stock of the main conceptions of mathematical terms in the 14th century. So for the sake of brevity, I refer to it as Pseudo-Marsilius questions on the physics. In the third question on book 6, Pseudo-Marsilius asks whether there is an indivisible thing, in res indivisibilis, within a continuum, such as a point within a line. And his answer is no, there is not. What is interesting about this question is a passage about the definition of terms like point, raised to defend what Aristotle states about points in his meteorology, namely that stars look like indivisibles and their conjunction does not make them look any bigger, exactly like conjoined indivisibles do not make any greater magnitude. Pseudo-Marsilius recalls 3 ways of conceiving mathematical terms that have been espoused by all those arguing against the existence of indivisible entities. So unfortunately, Pseudo-Marsilius does not say which way he prefers, nor does he engage with such a debate. So this passage actually remains just an excursus, although in a question on book 4, while dealing with the concept of void, Pseudo-Marsilius will seem to be more close to one of the 3 ways I'm about to present. All 3 views considered by Marsilius clearly refer to nominalist thinkers. And this means they all reject that the point is something different from the line, that is a real accident, and more in general, that mathematical items exist in the extramental reality. So let us have a look at the whole passage. So these are all work in progress translations. So if you have any remarks, I'm more than happy to consider them. So Pseudo-Marsilius writes, about this issue, there are 2 opposite stances, one of which posits that within a continuum, there are no indivisible things. For some say that all propositions like a point is, a line is, etc. are false, because in all them there is some term which does not stand for anything. Thus, they say that mathematical propositions, as well as some of those by Aristotle in Book 6 of the Physics, are to be understood only as conditional propositions. And I will call this the hypothetical way, A1, presenting empty terms and hypothetical propositions. The second view, A2, is the following. Moreover, others say that it does not matter such proposition a point is true, but for mathematicians, it is sufficient that the point is, the point is, punctum esse, is imaginable. For in the third book of Metaphysics, the commentator says that mathematical propositions are in the chapter on imaginable propositions. So this reference to Averroes' commentary on the Metaphysics doesn't seem to be correct. And I suggest Ps-Marsilius refers to Averroes' commentary on the Physics, where in the third book, it is explicitly said that all statement about addition of magnitudes, such as lines, planes, etc., are all opinabiles propositiones and have no existence but in the mind. So a thing worth noticing is that the process of addition of magnitudes Averroes introduces is exactly what Albert the Great puts forward to talk about geometric figures and imaginary movement. And we may call, by the way, this way of conceiving mathematical terms imaginative, because we have imaginable entities and hypothetical propositions. Finally, A3, the third way, Ps-Marsilius says, in saving such dicta, such as punctum esse, others posit that this term point is a privative name, and thus, just as this term magnitude stands for body, denoting its extension, in the same way the term point stands for the body, albeit not denoting the extension, but it stands for the body insofar as it is conceived in this respect, that is, as the end point of a distance or a magnitude. And we may call this the privative way, with point standing for body and denoting its non-extension. So I'm not sure all these definitions are correct, but as of now, I hope they are useful to orient ourselves. So just a quick recap. Those who reject the indivisibilist tenet, all of them agree on the fact that the term point does not refer to anything existing in reality. Yet they diverge on the way of considering the mathematical propositions, namely, those claims including mathematical words. And of course, they also diverge on the way they consider mathematical terms themselves. So first, we have those who take mathematical propositions conditionally, that is embedded in an if clause, because terms like point are empty. Therefore, the proposition a point is false and must be turned into if a point is. This is the basis of the hypothetical mathematics and physics, according to Gonard Roche. Second, A2, the imaginative way, which is developed by those who regard mathematical objects as imaginabilia, leaving out all concern about the truthfulness of mathematical propositions. So it doesn't matter such a statement, the point is, to be true, since mathematicians only need that point is imaginable. So the difference, I think, between the first and the second way is that in the latter, we can imagine that the point actually is something. And hence we can formulate hypothetical or conditional proposition. Third and last, A3, there are those who consider terms like point to be termini privationis, since they are stripped of their own supposition, and yet they denote something, still by means of a negation. So in this case, the point denotes the non-extension of a body. So at first sight, we might immediately recognize whose authors these views are, and we might already be thinking of Occam, Buridan, Orem, Albert of Saxony, Walter Burley, and Marsilius of Ingen himself, and you are right. Yet, things are a bit more nuanced than how Pseudo-Marsilius presents them, at least in my opinion, because it seems to me that the thinkers I just mentioned, Occam, Buridan, and so on, develop more than one view, or at least we can trace back more than one view to a single thinker. So in the remaining time, I will test Pseudo-Marsilius' threefold account and see to what extent it is useful to identify the main conceptions of mathematical terms in the 14th century. Of course, this is a very preliminary stage in my research, and my paper is certainly not exhaustive. So if I'm missing something, please point it out. So let's start with A1, the hypothetical way. Let us see if what Occam states about mathematical terms fits it. And I am relying mainly on Andrei Goddu's interpretation about that. In the Expositio on the Physics, commenting on a passage from Book 3 about the infinite, Occam stresses how often mathematicians use conditional propositions in their demonstrations and manipulate terms like infinite line, point, surface. And when they express a categorical statement like two parallel lines infinitely extended never intersect, they actually mean it as a hypothetical one, if two parallel lines, etc. But this is something, according to Occam, that applies only to those who deal with mathematics, non transgredientes limites mathematicae, and assume the point to be something indivisible and different from the line only as a working hypothesis, so to speak. So at this stage, Occam does not refer to the supposition of the mathematical terms, nor to mathematical objects imagined by mathematicians, but only to conditional propositions employed by mathematicians, used by mathematicians. So I'm not arguing that this is Occam's thought, but just analyzing the passage from the Expositio to see if it coincides with the reference given by Pseudo-Marsilius. And about that, Occam doesn't maintain, neither in the Expositio nor in other works, I think, that propositions like a point are false per se, like Pseudo-Marsilius stated about those embracing the hypothetical way. So the query then, it would seem to remain open. So about A2, the imaginative way, many authors seem to share this way, or at least refer to it. First, and again, Occam himself. I'm not going to read, as you have seen, I'm not going to read all the texts I'm sharing. So first and again, Occam. In a passage of his questions on the physics, the name point is not considered from the point of view of the virtus sermonis, nor is its supposition regarded. Occam's concern in this passage is the definition of the line in which the name point is introduced. So Occam stresses that the name point is introduced in such a definition based on the fact that mathematicians need to imagine such entities in their reasonings. So at this stage, in this specific passage, points are simply recalled as imaginable objects used by mathematicians, like we could say imaginabilia. So of course, Occam's account of terms like point is more complex than this, and I will come back to it later. But that geometrical entities like points are indeed imaginabilia, and therefore we can use such terms only within conditional propositions, is expressed in some of Niccolò Rem's works. And this is exactly what Pseudo-Marsilius has in mind, I believe, when describing the second imaginative way. For instance, in his questions on the physics, Orem deals with the notion of the infinite. The counter-argument that I reported on this slide has that no infinite line exists. Therefore, infinite cannot be taken categorematically, otherwise propositions about infinite lines are false. So to these, ORM replies by recalling the same passage of Averroes recalled by Ps-Marsilius, saying that mathematicians imagine certain things that are not in re, namely, they deal with imaginabilia. Nonetheless, mathematics is not a false science, according to ORM, because propositions on infinite lines are to be taken conditionally. But reference to points as imaginabilia is also present in Buridan's questions on the physics, and more precisely, the version called Tertia Lectura, transmitted in 4 manuscripts from the Vatican Library, Erfurt, Krakow, and Toulouse. This is something already pointed out by Joël Biard in his book Science et Nature, la théorie buridanienne du savoir. So I must say also, I am really grateful to Jean Célérette for sharing his transcriptions of question 4 from the Tertia Lectura with me. As we can see from this slide, also Buridan identifies 2 uses of the term point, the first one being secundum imaginationem. So in this sense, we are able to imagine that indivisible things are in a line, that such indivisible things are points ending or continuing the line, and that it is precisely on these points that the division of the line is made. But about this stance, we find an interesting correspondence in another version of the questions on the physics, still by Buridan. Jean Célérette believes this is a version in between the Ultima Lectura and the Tertia Lectura, and it is preserved in a manuscript from Cesena. So in the question on whether a point is an indivisible thing within a line, presented in book 3 of the physics, of Buridan's questions on the physics, we find the same reference to Averroes given by Ps-Marsilius and ORM. So the reference is made to strengthen the argument that points are imaginabilia or ficte imaginationes, fictive entities used by mathematicians in conditional propositions. So another thing about this passage that might be of interest for some of us, I think, is that when talking about points as imaginabilia, Buridan also refers to the chimera. But let us quickly turn to A3, the privative way. And it is quite easy to point to Occam, Buridan, Albert of Saxony, and perhaps a young Marsilius of Ingen. So let's start with Occam. And I'm sorry if I repeat some very well-known information. So Occam's account of point as a privative name can be found mainly in his questions on the physics and in his treatises on quantity and on the body of Christ. Occam's strategy in this passage exemplifies what William Courtenay remarked in an article about the meaning of the Virtus Sermonis. So this is Occam's strategy. Even before applying the supposition theory, one needs to translate the name point into proper terminology, and thus stick to the value or power of the name point itself. As we can read in his questions, point is a connotative name having only a nominal definition. This means that connotative names have a definition which includes both what is primarily and secondarily signified by their nominal definition. And I'm sorry for squeezing Occam's semantics and epistemology in such a way. I hope that specialists of medieval logic are not blacking out. In that case, I'm sorry. As for the connotative term point, the connotative name point, its nominal definition also includes a negation. And in this sense, it is a privative name. For point signifies a line of a certain quantity and no further extended, or linea non ulterius protensa, like it is said in his treatise on quantity. So still in the questions, this way of intending the dictio point is also referred to as improprium. Considering it by the power of its name, de virtutes sermonis, the proposition points is something, or the points is indivisible, are true. In this specific passage of the questions, the supposition of the name is not really addressed, the supposition of the name point, of course. Now, Occam offers other consideration of the term point, and as Eleanor Stump pointed out, it can be seen as an abbreviated expression, which is equivalent to the independent clause tanto protenditur linea et non ultra. And in this case, it surely does not stand for anything, but it can also be a figure of speech. But for reason of time, I leave those outside. So another account of point as a privative name is offered in Buridan's Quaestio de Punto, presenting a bolder statement than Occam's about its supposition. So the name point is like the name blindness, since it signifies a lack of divisibility or extension of a magnitude. Moreover, in the clause "the point is," the verb to be cannot express something true and positive about it, since point is a known ends, a known being. So in other words, the verb to be, est, within the clause point est in linea, for instance, is not a proper copula. Otherwise, we would have an inference of the kind, the point is in a line, therefore the point is, that is, it exists. So while Occam, in the passage we considered, limited himself to talking about the virtus sermonis of the name point without explicitly, and I remark explicitly, so without explicitly saying something about its supposition, Buridan, at least in his Quaestio de Punto, clearly states that this name does not refer to anything. However, like Jean Celerette and Joël Biard have shown, this opinion, though, seems to change in his questions on the physics secundum tertia lecturam, where it is stated that the names point, line, surface, and body, they all stand for the same magnitude on different accounts, namely, inasmuch as the magnitude is conceived as divisible according to width, length, and depth, which are called diametry. So that when we conceive of magnitude as divisible into 3 diametry or dimensions, it is referred to by the name body. When we conceive it as divisible into 2 diametry, the name surface stands for it, and so on until the name point, who stands for magnitudes understood as being relieved from all divisibility. So another privative conception that we could take into account is developed by Albert of Saxony, although it is quite close to what Buridan also states in both the tertia and ultima lectura of his questions on the physics. I'm not sure I totally get the Latin here, so I'm not even sure about my translation, but I think, so of course, every insight on the Latin is more than welcome, but I think the meaning of the whole passage is that although the name point is a privative name signifying the lack of divisibility, such lack of divisibility is to be understood in a distributive way. Namely, the name point signifies a part of a line and yet not a part of the whole line. But again, I'm not sure about my reading, and I'd be glad to hear what you think about it. So one last small reference still about the privative name, which it could be useful to compare Pseudo-Marsilius and the real Marsilius of Ingen. So in my brief survey of the authors adopting the imaginative solution, I haven't mentioned Marsilius of Ingen's account of mathematical items as imaginabilia. In a passage of his commentary on the sentence, Book 2, a young Marsilius seems to commit to the privative way as far as the name point is concerned. However, Graziana Ciolla's studies have convincingly shown that Marsilius rather conceives mathematical items as relative impossibilities, different from absolute impossibilities like those entities composed by incompossible forms, such as the chimera. So as I said earlier, Pseudo-Marsilius does not tell how he looks at the term point. Yet, there is a small clue that could help us figure out his stance on this issue and maybe distinguish him from Marsilius of Ingen. But of course, This is just a working hypothesis. We all know that the term void is very often associated to the term point, being it as well considered as a privative name, for instance, by Buridan, but also by Albert of Saxony, for instance. Well, when asking if it is possible that, that the void exists, Ps-Marsilius replies in a way that is really close to what we just read about Buridan and his account of the name point, but also to what Albert states about the void itself. So in fact, Ps-Marsilius firstly says that the name void is privative, as it signifies place filled with no body. So like Buridan and Albert, he stresses that the verb to be actually signifies to mean. So if point is to be taken like void, we might assume that Ps-Marsilius tends toward the privative way, in this differing then from Marsilius of Ingen. But it's, again, of course, it's just a suggestion, and surely more research needs to be carried out. Now I think it's time for some conclusions. So we started from Ps-Marsilius' account of 3 different ways of conceiving mathematical terms. So my intention was not to reconstruct the thought of all thinkers I dealt with. Rather, my aim was less ambitious, as I just wanted to take Ps-Marsilius' description seriously and see if it works. So I tried to test such account and to show that the 3 main ways presented by Ps-Marsilius actually mark the 14th century debate. But it seems that some thinkers commit to more than one way. This has been the case with Buridan, for instance, and it might be, at least, that some works by the same author could represent the starting point to develop more than one way. So on the one hand, Ps-Marsilius' threefold layout proves to be a good mind map to orient within the 14th century discussions on mathematical terms, within the nominalist tradition, of course. And on the other hand, if we go into details, it looks like the overview should be more attenuated, nuanced. So one last thing that I would like to remark. I opened my talk with Albert the Great's role of imagination in conceiving mathematical objects. In his notion of imaginary movement, Averroes' account of the flow of the point toward 3 dimensions resounds, and it does so still in some 14th century authors like Buridan and Rem, especially concerning Rem in his questions on Euclid, which I haven't mentioned though. So although Albert the Great never engaged, of course, with any metalinguistic analysis of the geometrical terms when dealing with the continuum, the notion of mathematical ficta, or imaginable mathematical entities, is already present in Albert, to the point that when Roger Bacon criticizes his epistemology of mathematics, Bacon precisely targets the role played by imagination, calling Albert's conception of mathematical items precisely as ficta. So I'm sorry for the jump back to the 13th century, but I just wanted to glimpse at these possible routes for the 14th century mathematical imaginabilia. So to answer the question in the title of my talk, it will seem that we do imagine points some way, and we also use terms like points, assuming they are in our imagination only, although, of course, this is not the only way we can analyze them or metalinguistically conceive them. And thank you for your attention.
Thank you, Clelia, for this very interesting talk.